Okay, so we've done factoring of x squared plus bx plus c and ax squared plus bx plus c. And we're going to look at today perfect square trinomials and then the difference of two squares. And go through those. So here is what perfect square trinomials look like. And this is something that's very important that we will actually return to perfect square trinomials quite often because they actually teach us how to do squaring, and we'll actually use that a lot in the things that we're going to be doing. And if you can understand that when I square a plus b, that I get this, then you can actually work through some shortcuts later on in this class, in Algebra C, and if you go on to pre-calc, we use it a lot. So, right? So we have perfect square trinomials that we're going to factor first of all, and then we're going to go ahead and look at difference of two squares. But notice, when we have a perfect square trinomial, like x squared plus 6x plus 9, if I factor it, then the factors are the same. Okay? So then I'll write it as the single factor squared. Okay? So we're looking at factoring them. So the first thing is that you've got to know, is it a factorable or not? So is it a perfect square trinomial? So here we have 9x squared minus 15x plus 64. And we're going to determine whether it's a perfect square trinomial. And then if it is, we're going to factor it. So when I'm looking at whether something is a perfect square or not, first thing I'm going to do is I'm going to look at the first term. So I'm going to look here and here and see if those are perfect squares, first of all. Okay? And not only if they're perfect squares, but what is being squared there. So what's being squared here to get 9x squared? What squared is 9? 3. And what squared makes x squared? X. Okay, so this is 3x squared here. Okay. And what about 64? What's squared there? 8. Okay. Now, according to our information then for that this is ax squared plus 2ab plus b squared, that tells us that a is equal to 3x and b is equal to 8. Now the question I need to answer is, does 2ab, right, the middle term, does that equal negative 15x? If it does, it's a perfect square trinomial. If not, then I want a new one.
Well, you could change it.
Oh, okay. Yep. That happens. Should I tell you what my password is then so you can get on? All right. So we want to multiply 3x and 8 together, multiply it by 2, and does it equal negative 15x? If that's true, then this is a perfect square trinomial. If it's false, then it's not. Okay? So when we do 2 times 3x times 8, let's see, 6 times 8 is 48, right? So this should be 48x. Is that equal to negative 15? No. Okay, so this is not a perfect square trinomial. So we're looking to see if the first and last terms are squares. Okay. If they are, then I check to see if the middle term is equal to 2 times those two things that are squared. All right, so let's look at another one. Letter B. So is 81x squared, is that a square? Okay, so what's being squared there? Okay, so this is 9x squared here. And 25, is that a square? Okay, so that's 5 squared. Okay. So does 2 times 9x times 5 equal 90x? Okay, if it does, then it's a perfect square trinomial. If not, then it isn't. So 2 times 9 is 18. Oh, there's an easier way, right? 2 times 5 is 10, and 10 times 9 is 90. Okay, so this is true. So it is a perfect square trinomial. So I'm going to factor it. And what two numbers go in my factor? 9x and 5. So the answer is yes, it is. And we have that 9x plus 5, that quantity squared, is the factorization of it. Now, a lot of these, you're going to be able to look at them and say yes or no right away. Okay. So letter C. Is that a perfect square trinomial? No. Mitch, why not? Okay, because this is not, because 14 is not a square. So this is not. A rectangular piece of cloth must be cut to make a tablecloth. The area needed is 16x squared minus 24x plus 9 square inches. The dimensions of the cloth are of the form cx minus d, where c and d are whole numbers. Find an expression for the perimeter of the cloth. Find the perimeter when x equals 11 inches. Okay? So it says a rectangular piece of cloth must be cut to make a tablecloth. So we want to be able to factor this then, to see if we can find the dimensions of this tablecloth. So the first thing, we're working on perfect square trinomials, right? Okay. So is this a perfect square trinomial? Okay. Yes? Okay. Is the middle term work? Yes? All right, so now after the interruption. Okay, so this is a perfect square trinomial. So let's figure out what it is. So we got 16x squared. What's squared there? 4x. Okay, so we have 4x is squared. And the 9 is 3 squared. Okay. And so 2 times 4x times 3, does that equal 24? X is equal to 24x. And the answer is yes, okay? So this is a perfect square trinomial. And in factored form, it's going to be 4x minus 3 minus, okay, notice it's minus, whatever the sign of this is here, that's the sign that goes in the middle between them. So 4x minus 3, that quantity squared. That's the area of this cloth. Right? They want us to find the perimeter. So what does that tell us about the perimeter? So we're dealing with a square, aren't we? Okay. So we've got a square here. Okay. What's the length of each side of that square? What's the length of each side of the square? 4x minus 3. And why is that, Dylan? Okay. Okay. Yep. All right. It's a square. And since it's squared, that means that all of these are 4x minus 3. So how do I find the perimeter then? Okay. I can add up 4x minus 3 for each side, or I can do what? Times it by 4. Good. So our perimeter is 4 times 4x minus 3, which is what? Okay, 16x minus 12. Okay, there's one of our answers. All right, for the perimeter. But then it says find the perimeter when x equals 11. Okay, so we'll do perimeter is equal to 16 times 11 minus 12. Okay. Or you can do that. This is 4 times 11 minus 3. Let's see, 44 minus 3 is 41, right? And then just multiply that by 4. So either way you want to do it, you'll get 164. And that would be 164 what, Justin? Inches or square inches? Which one is it? Because the table, just inches, right? Okay, if we're talking about distance around the outside, if this is to the first power, that means it's linear, one-dimensional, so we have inches. If it was to the second power, like this is, so this would be square inches. But you don't say inches squared, we say square inches. Okay, questions on that? All right, you got perfect square trinomials? Piece of cake? All right. Okay. Chocolate cake with a white frosting, right? Does that sound good right now? Do you have first lunch or second? First? All right, so you've only got about 20 minutes. All right? Okay, difference of two squares. I love difference of two squares. The only thing is with difference of two squares is some people get the two mixed up between perfect square trinomials and difference of two squares. Difference of two squares only has two terms. Okay? A squared minus b squared. Perfect square trinomials, okay, what's the key word there? Trinomial, and trinomial means three parts, okay, three terms. So difference of two squares means I'm taking two squares and subtracting them. Perfect square trinomial means I have three terms. So the difference of two squares, if I have a squared minus b squared and I factor it, we get the quantity a plus b times the quantity a minus b. So here they give us an example, x squared minus 9 would be x plus 3 times the quantity x minus 3. I like that one because it's always usually pretty straightforward and the easiest to factor. So here we want to, first of all, determine whether these are the difference of two squares. And if they are, we want to factor it. Letter A, 3p squared minus 9q to the fourth. Is that the difference of two squares? Is 3p squared, is that a square? Is 3 a square? No, no. 3 is not a square, so this is not. Three is not a square. But what about, just to look at it for a second, what about 9q to the fourth? Is that a square? Lexi, is it? What would the square, what's squared there? Yep, 3q squared. So this part is, okay, but the other part is not. So the thing is, if we're talking about squares, all I have to do is take the exponent and cut it in half. Okay. If we're talking about cubes, we cut it in thirds. Okay. How about letter B? Is that the difference of two squares? Okay. So what's being squared there, Kylie? Okay. 10 and 2. Okay. 10x and 2y. All right. So we've got 10x is squared here, and 2y is squared there. So those are my values of a and b. So we have 10x minus 2y and 10x plus 2y. Does anybody know that you can do that one a different way? One of the things that when you're factoring is you should always look to see if they have a greatest common factor. Okay? Anybody not know what greatest common factor is? Okay? What do they have in common? Okay? So do 100x squared and negative 4y squared, do they have anything in common? Okay? They have 4 in common, right? So I could, in this case, it'll look differently, but it's the same answer. I could write this as 4 times 25x squared minus y squared. Now, is this part here the difference of two squares? This is 5x is squared here, right? And just y is squared there. So I could write this also as, oops, not plus, So my answer could be either one of these. And it would be correct. Okay. Those are both the same.